Okay, so this section we have to discuss the data cleansing. This is part of descriptive statistics. Now, the data in dataset are often said to be dirty and raw before they have been put into a form that is best suited for investigation, analysis, and modeling. So we need to prepare the data and make it heavy use of the descriptive statistics and data visualization to gain understanding on the data. So the common tasks in data preparation include treating missing data, identifying erroneous data and outliers, and defining appropriate way to represent variables. So now we have here missing data. We have the data sets are commonly include observations with missing values for one or more variables. So in some cases, missing data naturally occur, and they are called the legitimately missing data. For example, like if respondents to a survey may be asked if they belong to a fraternity or a sorority, and if the respondent want to skip that question, then asked how long they have belonged to a fraternity or sorority. If the respondent does not belong to any of the fraternity or sorority, then she or he should skip the question about how long. So the remedial action taken or the legitimately missing data. So there's no remedial action to be taken for skipping the question. Now, in some cases, missing data occur for several reasons, and they are called the illegitimately missing data. These cases can result for a variety of reasons, such as respondent electing not to answer a question that he or she is expected to answer. And in other cases, like missing data occur for different reasons, and there are primary options for addressing such missing data. Like here, we have to discard observations. Like for observations, they are the raw or the rows which with any missing values. Second is to discard any variable or column with missing values. Third is to fill in missing entries with estimated values. Okay. And lastly is to apply a data mining algorithm that can handle missing values. So those are the primary options for addressing the missing data. Now, deciding on a strategy for dealing with missing data requires some understanding of why the data are missing and the potential impact these missing values might have on an analysis. Then, if the tendency of for an observation to be missing the value for some variable is entirely random, then whether data are missing does not depend on either the value of the missing data or the value of any other variable in the data. So they are called the missing completely at random, or the MCAR. Now, missing at random, this is the tendency for an observation to be missing a value for some variable which is related to the value of some other variables in the data. Then, missing not at random, this is the tendency for the value of a variable to be missing is related to the value that is missing. So MNAR, this is the third category. For example, the survey respondents with high incomes may be less inclined than respondents with lower incomes to respond to the question on annual income, and so these missing data for annual income are missing not at random. For missing at random, for example, if the responses to one survey question collected by a specific employee were lost due to a data entry error, then the treatment of the missing data may be less critical. So, however, in the health case or healthcare study, suppose observations corresponding to patient visits are missing the results of diagnostic tests, whether the doctor deems the patient too sick to undergo the procedure. So in this case, the absence of variable measurement actually provides additional information about the patient's condition. Now we have here for data cleansing, let's try to apply this Blakely tires. This is a US producer of automobiles tires that want to learn about the conditions of its tires on automobiles on Texas. So the data obtained includes the position of the tire on the automobile, age of the tire, mileage on the tire, and depth of the remaining tread on the tire. Now, try to go to the data and let's try to look for the missing data. Now, this is the data set of the tread wear. Okay, tread wear of the Blakely tires. Now, we begin assessing the quality of this data by determining which observations have missing values for any of the variables in the tread wear data. So we can do using the Excel's function count blank. So let's have to position on where to enter the heading and the count. Now in G2, we have here, let's try to have a label of number of missing values. And then in H1, okay, let's have a column label for the life of tire that's in terms of months. Okay. So we have already the labels for the rows and the label for column, in which this one is the life of tire in terms of months. And now let's have to look for the blank values or the missing values. Let's try to enter the formula count blank. So this count blank, okay, is to count the number of cells with no entry. So for this one, we have to count the blank cells of the life of tire. Okay, so the range is from C2 until the end of the data set. Sorry. Okay, from C2 until C457. Then press enter. So now there is no missing values for life of tires. Now, since we're going to look for the missing data for the tread depth and miles, we can just copy the label here, copy and put it here, and the same formula for the tread depth and miles. Okay, so we have here one missing data for the miles. Okay, now let's proceed to the next one. The next here in cell G3, we're going to get the mean. Okay, and here we will get the standard deviation. Okay, in which again we can get the mean of having the average function. Okay, the mean of life of tire. Okay, so we have 23. Okay, also get the mean of tread depth and miles. Okay, make sure that the range of cells for the miles must be E2 until E457. Okay, now for the standard deviation, the formula is equals ST div S. Okay, standard deviation of the life of tire, we have here from cell C2 until C457, and also get the standard deviation of tread depth and miles. All right, now the next one is get the minimum and maximum value. So here, the minimum and maximum. Okay. So the minimum value for the life of tire, again, use the Excel formula equals mean. Okay, from cell C2 until C457. Okay. Then we must have to get the minimum value also of the tread depth and miles, and the maximum value of life of tires. We have equals max from here until the last. Then we have here. Okay. So we have already entered the necessary formula to get the minimum, maximum, standard deviation, mean, and number of missing values. Now, we can go to the variable representation. Okay, for the variable representation, like we have to get the dimension reduction. This one, so this figure shows the portion of Excel spreadsheet showing the number of missing values for variables treadwear data. And this shows the portion of Excel showing the treadwear